Hey guys, today we are talking about factoring difference of squares. Now here's the thing. Yesterday we learned all about factoring trinomials. Well, in certain specific cases we can factor even if it's just a binomial, meaning when it's just two terms. So if there are two terms like a squared minus b squared, we know from a very special rule that we can factor it out to be a plus b times a minus b. Now this only works if we are subtracting. So that's why it's called difference of squares, and it only works if both numbers are perfect squares. Let's take a look at an example. Number 1 here, I have x squared minus 9. So x squared is obviously a perfect square, and 9 is a perfect square. Okay? I want you to think about this with me. X is a perfect square here, okay? And 9 is also a perfect square. 9 is 3 squared. 3 times 3 is 9. So we are going to replace this with 3 squared. That way, it lines up like with this a and this b. So what this means is my a is x for this problem, and my b is 3. Okay, so now I can write out my difference of squares. Okay, so we take it and we're going to write out just like this. We're going to go x plus 3 times x minus 3. Just like that, okay? X plus 3 times x minus 3. Okay, my first number that was squared plus my second number that was squared times my first number that was squared minus my second number. Okay, and that is how you factor out difference of squares. So it might really benefit us to think about what are some common square numbers, right? And so my perfect squares are 1, 4, 9, 25, 36, 49, and so on and so forth. So if you see any perfect squared numbers, it's probably going to end up like this. So let's move on here to number 2. So number 2, we have 25n squared minus 49. Okay, well, 25n squared. That's the same thing as saying 5n squared, okay? Right? Because 5n times 5n is 25n squared. So this is a perfect square. The same thing is true for 49. 49 is 7 squared. So there we have it. 5n squared minus 7 squared. So my A is 5n and my B is 7. So now we just kind of follow this formula, right? We just kind of plug those in. You can kind of build your parentheses. We're going to have a plus here, a minus here, right? And then we just plug in my A and B and A and B. It really is just a formula that we use to split it up. The only hard part is that we have to figure out what my A and B are. So first off, my A, 5n, my B, 7, my A, 5n, my B, 7. So it's 5n plus 7 times 5n minus 7. Okay, let's take a look here at number 3. So number 3, we need to factor this. But wait, remember, always, always, always check for a GCF first. You'll notice I was lazy. I didn't check for GCF on 1 and 2, but this one has a GCF, doesn't it? This one has a GCF, and that GCF is 3x. Okay? So this one's going to be, we're going to have to pull out a 3x first. So we're going to divide this by 3x, divide this by 3x, and so we're going to get 3x times, in my parentheses, 4x squared minus 1. Okay? So then, now we're going to stop and we're going to break this down to find what my A and my B is. You might be confused by that 1 there. Well, whenever you see 1, you should see alarm bells going off in your head, be like, oh, 1 is like the ultimate perfect square. It can just be squared and squared and squared again, and it always is just 1. So, for this one, 4x squared is the same thing as saying 2x squared, and this is just 1 squared, okay? And we still have this 3x out in front that we kind of ignored. So this means that my A is 2x, my B is 1. So we leave the 3x out in front, and then we're going to build my parentheses, have a plus here, a minus here. My A is 2x, my B is 1. My A is 2x, my B is 1. So it goes just like that. 3x times 2x plus 1 times 2x minus 1. And so there are my factors. So remember, always look for a GCF first. Okay, number 4 here. We have a w squared over 169 minus y squared over 100. Don't let the fractions freak you out, guys. We're just thinking all of these are squared, okay? Look at this. W squared is just w over the square root of 169 is, you guessed it, 13. Or maybe you didn't guess it. But remember, you can use your calculator to find what's squared. Just type in your calculator, okay, what's 11 squared, what's 12 squared, what's 13 squared, and you'll find it eventually. So that's 13 squared. So it's w over 13 squared minus y over 10. Because 10 times 10 is 100. See how I split this up? 13 squared is 169. 10 squared is 100. So my A is w over 13, and my B is y over 10. So now we're still going to build out my parentheses. Still going to put a plus sign and a minus sign. And we're going to plug in my A and my B, right? We're going to go w over 13 plus y over 10, w over 13 minus y over 10. Okay? So there is my all factored out. Okay? It's just a special rule. Like it's a special case. It doesn't happen all the time. In fact, it's not going to happen right here. Number 5. Look at this guy. Y squared plus 9. Well, I hate to break it to you, y squared plus 9 doesn't factor. And you might be like, Mr. Martin, y squared is a perfect square. 9 is a perfect square. We did this one earlier. Well, remember what I said. It only works if there is a minus. This one has a plus, and so it doesn't actually work. So this one is a cannot factor. Okay, number 6. Ooh, I think we have a GCF here to start. Let's see here. GCF is going to be 3. We can divide this one by 3 and divide this one by 3, right? So let's pull out a 3. Divide both those by 3. We're going to have x squared minus 9. And then here is one that I can factor because both of these are perfect squares and it has a minus in the center. So my A is going to be x squared minus 3 squared, right? 3 times 3 is 9. So my A is going to be x, and my B is going to be 3. So it's going to be 3 times, and we'll build my parentheses, put a plus, put a minus, x plus 3, x minus 3. Okay? And there you go. There is our factors. All right, very last one, number 7. Number 7, I have 6x squared plus 4x minus 10. Wait a second, this one isn't a difference of squares. This is one like what we did yesterday. So let's do it like we did yesterday. It's a trinomial. So let's first look for a GCF. And my GCF is going to be 2. So we're going to divide each one of these by 2. So we can go 2 times 3x squared plus 2x minus 5. Then we're going to build my x and my plus. So remember your x, we have a times c on top, and on bottom we have b. So a times c, 3 times negative 5. So we're going to have a negative 15 on top, and we're going to have a 2 on bottom. So I need to think of two numbers that multiply to equal negative 15 and add to equal 2. And those two numbers are going to be 5 and negative 3. 5 times negative 3 is negative 15. 5 plus negative 3 is 2. So then we build our plus sign. And remember, it's ax, ax. Now, something I might have skipped. Remember, this is my a, this is my b, this is my c. This 2 in front is just my greatest common factor. It is not your a. So that a is just going to be 3, so we're just going to have a 3x and a 3x. And my two numbers we bring over, we're going to have a 5 and we're going to have a negative 3. So now we can write my factors. We have a 2 out in front, that's my GCF, and my first factor is this one, 3x minus 5. And 3x minus 5 can't reduce at all, so we just leave it like that. My next one, 3x minus 3. Wait, this one can reduce. We could divide both of these by 3, right? And so that's going to make my new factor of x minus 1. So there are my factors. 2 times 3x minus 5 times x minus 1. So now we'll just check our answer. Oh, and I messed up, didn't I? I wrote a minus 5 right here. It should be a plus 5. Good thing I checked my answer, because 5 times negative 1 is a negative 5. 3x times x is 3x squared, so it makes sense. All right, guys, that has been factoring difference of squares and kind of a refresh on a little bit of what we did yesterday. I hope this video was helpful, and I hope you have a great rest of your day.